In this lesson, I'm going to introduce cross products and explain what the physical interpretation is. If you're actually looking for how to calculate a cross product, that's in the next lesson. It's called Cross Products and the Equation of a Plane. The cross product is another way of multiplying vectors. This time the cross product of two vectors is going to be another vector. And the rule is u cross v is perpendicular to both u and v. And it has this formula for the magnitude. So you'll see some similarities between the cross product and the dot product. One thing that just sort of helps me put the right peg in the right hole is to remember that cross product is associated with sine and dot product is associated with cosine. So the issue is this definition doesn't uniquely define one answer. I've drawn the vectors u and v, and the goal is for us to draw a vector that's perpendicular to both of them. So the red box there is the plane that contains the vectors u and v, and there's actually two answers, right? That is one possible choice for the cross product, and then this one that goes the other way, that's another choice. Both of those vectors that I drew are perpendicular to u and v. So how do we choose? The answer is the right-hand rule. So I've got to draw a hand, so I'm going to do my best. So you put the first vector, in this case we're trying to work out what u cross v is. So you put your index finger down the vector u, and then you put your middle finger down the vector v, and then there's your other fingers just tucked in there. They don't matter. And then whichever way your thumb points, oh goodness, okay, there's my hand drawing, somebody help me. Whichever way your thumb points is the result. So in this case, my thumb is pointing in the direction of u cross v because my index finger goes down u and my middle finger goes down v. So you can see actually that if I reversed that, if I put my first finger down v and my index finger down u, then my thumb would point in the other direction. So geometrically, when you calculate a cross product, every time you've got to do some kind of silly dance with your hand to figure out which way the resulting u cross v goes one way and v cross u goes the other way. Here's some nice properties of the cross product. I just want to point out property 3 is actually the property that I was just explaining, how when you reverse your order, then the vector is pointing in the other direction. This one is u cross v, and then this one that goes that way is v cross u. So since those two vectors point in opposite directions, that's what that negative sign in front of vectors means. So you really should familiarize yourself with these properties of the cross product and be comfortable with them so that you can do algebraic manipulations. It's surprising how often in math you have to calculate the area of a parallelogram, and there is a relationship between the area of a parallelogram and the cross product. So let's just build a little parallelogram here. And then just from basic algebra, the area of a parallelogram is the base. Did I say algebra? Geometry. The base times the height. So obviously the base of this parallelogram is the magnitude of u. So I need to figure out the height. So let me just drop this perpendicular down right there. So I've got a right triangle to work with. And then I'll name the angle between the two vectors theta, and I'm going to name that height that we're looking for, h. Okay, so from right triangle trigonometry, I have an opposite and a hypotenuse. So the sine of theta is equal to the opposite over the hypotenuse. So the hypotenuse there is going to be the magnitude of v. So this means that h is equal to magnitude of v sine theta. So let's plug this into our area formula. So the area is going to be the base. That's the magnitude of u. And then the height is the magnitude of v times the sine of theta. So look at that. Look at that. That's just beautiful. The cross product is a way to combine two vectors that produces another vector. It always produces a vector that's perpendicular to both of the original vectors, and it follows the right-hand rule. And the magnitude of the cross product gives you the area of the parallelogram that those vectors form. Torque is the amount of rotational force. So we imagine in this case, I've drawn a bolt and a wrench. So in this case, righty-tighty, I would imagine the bolt being driven into the page here. So the torque is actually a vector that goes straight into the page. Okay, so how much rotational force do you have? Well, the law of the lever says if you have a longer wrench, then you're going to have more force because you have more mechanical advantage. And then obviously, if you push more force on the end of the wrench, then that will produce more force as well. But it also depends on the angle that you're pushing on. Observe that actually, if you put the force in that direction, nothing will happen, right? So the most that you can get out of it is if the force is exactly this way. And then, this is some kind of like halfway in between. Not all of the force is going into twisting the wrench. Some of the force in this case would actually just go into compressing the wrench and making a little bit shorter. So torque is largest when the two things are perpendicular to each other, and it's 0 when the two things are parallel to each other. So do we have a function that does that? Yes, we do. That's exactly what the sine does. So this means that there's a relationship between the cross product and the torque. All right, I had to pause the video while I drew this hand. This is the best hand that I can draw. But since righty-tighty, lefty-loosey, we have to define the torque. So R goes from the bolt out to the end of the wrench, and then F goes from the end of the wrench in whichever direction it's pointing in. So according to the right-hand rule, the torque should be the radius cross product with the force. That way, when you go to the right, that drives the bolt down and tightens the bolt. And then the magnitude of the torque is given by the same formula as the cross product. So here's an example where we're asked to calculate torque, and we've got a little picture of a monkey wrench. And they give us the angle, and they ask us to calculate the total amount of torque. So here in this problem, the magnitude of the force is 30 pounds. And it's a regular sized monkey wrench. It's 4 inches long. So first of all, the units of force in the imperial units are foot-pounds. So I have inch-pounds here. So first of all, 4 inches times, there is in 1 foot, there are 12 inches. So this means the magnitude of PQ is actually 1/3 of a foot. So now the torque, the magnitude of the torque, that's what we're asked to do, is just find the magnitude of the torque. Where did the problem go? Find the magnitude of the torque. So this will be the magnitude of R times the magnitude of F times the sine of the angle between them. So this is going to be 1/3 times the magnitude of F, that was 30, times the sine of 60 degrees. So 10 times the sine of 60, square root of 3 over 2. So I get 5 square root of 3, and then, just follow whatever appropriate rounding directions there are. And then these units are foot-pounds. Those are the imperial units of force. So one thing that I didn't teach you in this lesson is how do you calculate the cross product? So it's just a mechanical process. It's not hard, but it is a little bit complicated. So I saved that for the next lesson. So just go ahead and dive into the next lesson, and I'll go over how you find the actual cross product between two vectors, and also how you write the equation of a plane through 3 points.